In this video, we'll be discussing Module 6, Error Checking and Data Validation. So what is error checking? Simply put, error checking is walking through the logic of your program to make sure that it is correct not only from a syntax standpoint, but from a logic standpoint. It's important when designing a program to make sure the errors are eliminated before the final version of the program, because not all errors are syntax errors. So syntax errors are errors in the way the code is written. So if you made a typo in a keyword or something like that, or if in some programming languages it requires parentheses around certain things, quotation marks around certain things, or a semicolon at the end of the code, the line of code. So these type of things, if a symbol is left out that's supposed to be there, that would all be considered syntax errors. And generally, syntax errors will lead to the code not running, or running to a certain point and then having an error. As you've used Flogorithm, you may have encountered this, because if something is not entered correctly in Flogorithm, syntax-wise, then when you try to run the program, it will give you an error. Logic errors are harder to identify because they may not cause the program to stop running. So a logic error is an error in the way the program is processing the data. So even if your syntax is correct, it may not be producing the correct output if the logic has an error in it. But because the program may continue running, it may be harder to catch those logic errors. So it's important to walk through the program logic step by step to be sure the data will be processed appropriately. And it's important to know what you are expecting to get out of the program. So when it comes to things like mathematical calculations, for instance, you would want to manually calculate a few answers and then run your program to be sure that it is producing the correct output. And if it's not, then revisit the way that you typed out your calculations. With math especially, it's important to pay close attention to the order of operations. In our example here, we'll see that. So kind of revisit math class, PEMDAS, so parentheses, exponents, multiplication, division, and then addition and subtraction. That's the order in which the calculation will run. You also want to reread the problem statement to be sure that the program meets all of the original requirements. So is it getting the correct data from the user? Is it producing the required output? And have any controls been put in place to monitor or to control the type of data that is entered by the user, and reject any incorrect data? So let's look at this flowchart here, and I want you to try to find the error. So we're going to walk through this. And as a reminder, this is a flowchart we've looked at before. The problem statement is a program is required to get a set of 15 temperatures in Fahrenheit from a user. Convert each one to Celsius and display each temperature in Celsius. All right, so I'm going to pull this up in Flogorithm, and I'm also going to pull up my calculator so that we can test this calculation. All right, so I got this conversion for Fahrenheit to Celsius temperature by Googling it. So I know that my equation is correct. So let's see, for example, we'll do an easy and kind of obvious one. So 32 degrees Fahrenheit should equal 0 degrees Celsius. If I do 32 minus 32, times 5/9, it equals 0. I can also try out 100 degrees. That should give me 37.77777. So when I run this program, those are the results I should get for those two temperatures, 32 degrees Fahrenheit and 100 degrees Fahrenheit. So let's run it. I'll enter just those couple of temperatures to see how they process. All right, so I can see from just my first couple of outputs that this is not what I'm expecting. The temperature in Celsius is 14 degrees for my input of 32. The temperature in Celsius is 82 degrees for my input of 100. And what we were expecting was 0 degrees and 37 or 38 degrees because it will round. So I need to revisit my calculation. So let's look at our calculation here. And it's important to think literally, how is the computer going to process this? All right, so on my calculator, I'm going to calculate exactly how the computer would look at this. All right, so let's say I've put in my input of 32, and it will look at C temp equal to 32 minus 32 times 5/9. But according to the order of operations, the first thing it will do is calculate what's in parentheses. So 5 divided by 9. All right, 0.55555. And it will multiply that by 32 because multiplication and division come next. So times 32, okay? And then it will process addition or subtraction. So it will subtract 17.7777 from, or subtract that from 32. So 32 minus 17.77777. And that gives us our answer that we saw in the output. So, and again with the example of 100, so we would have 5 divided by 9 times 32, okay, and then 100 minus 17.7777, and it gives us 82, which is, again, the output that we saw. So what is the problem? Well, because we are expecting to subtract 32 from the Fahrenheit temperature initially, that's not the way this program is running because of the order of operations. So if we open up this calculation, we would simply need to put this, the Fahrenheit temperature minus 32, in parentheses so that that will run first. That way it arrives at this number before multiplying it by 5/9. Okay, so if I change that and run it again, let's see how that works out. 32, 100. All right, so now I can see that when I put in 32, the answer is 0 degrees. When I put in 100, the result is 37 degrees. So now we are getting the expected results from this program. So we can see that just that simple order of operations, not typing in the calculation correctly, the program still ran, it processed the data, but it was not giving us the correct results. So it's important to look at that, figure out what is the correct answer, and is the program giving the correct answer every time. Another important thing to include in your programs is instructions and feedback. So you want to include instructions in a program so users know how to interact with the program and what to expect. You want to tell the user what they should input and make it clear what is valid or invalid input. So if you can design a program in Flowgorithm that simply asks for input and then processes it and displays some output. But it won't give the user an explanation. And remember, the user, if someone new just sits down to use your program, they should be able to use your program without having to get you to explain what the program is doing and what they are supposed to be doing and what they're supposed to type in. So in Flowgorithm, you can use the output shape, the output keyword, just to display a message. It doesn't always mean that that is the end result of the program. Output just means that you're displaying something to the screen. So you can use that to give the user instructions before they even put in any input. If the user does enter invalid input, then you want to give them feedback that doesn't just say, you want to avoid vague error messages, so you don't want to just say, oh, error in your input. You want to explain why it was invalid. So is it because they put text in when they were supposed to put a number? Is it because they entered a number outside of an expected range? Is it because they put in a negative number and they can only use positive numbers? So you need to explain the problem and remind the user of what is valid. Related to this is data validation. So data validation is a method of confirming that data entered by a user is correct before processing it. The purpose is to check whether the data entered is the correct type and whether it is within an acceptable range. So again, if you have assigned a variable to be an integer and a user types in text, that's not going to work. You want to make sure that it will not try to process that, and also even if they enter a number, in some cases there's a range of numbers that you would want to keep that input within, otherwise it wouldn't make sense. For example, with our exam scores, which is part of your assignment, it wouldn't make sense for an exam score to be outside the range of 1 to 100. So if a user types in 800, chances are they meant 80 and it was a typo. So you want to filter those kinds of things out to help out your users. If it's not valid, if the data that they input is not valid, it should not be processed. So you have to implement some way to filter out what is not valid. Because remember, if you've ever had anything to do with programming, you're probably familiar with this phrase, GIGO, garbage in, garbage out. So if you put garbage in, you're going to get garbage out. If you use a rotten apple like the one in the picture, and you cut that up and try to make an apple pie, you cannot expect to get a beautiful, delicious apple pie like in the bottom picture out of that rotten apple. What you put in is what you're going to get out. So if you put a rotten apple in, you are going to get a nasty apple pie that does not look appetizing and probably doesn't smell good either. So it's the same with programming. You can't expect to allow users to put in invalid data and get correct output from that. So if a user enters invalid data, as we mentioned before, the program should provide instructions on how to correct the problem and allow the user to try again. So this is where loops can come in handy, that if they put in invalid input, it will allow them to try again and continue checking that until they put in data that is valid. So here's an example of that. Revisiting one of our previous programs, where the user enters the current temperature and then the program simply categorizes and displays a message of whether the current temperature is hot, moderate, or cold. So we could have a pretty big range of valid temperatures, but if they were to put in something like 1,000, that is not a valid temperature here on Earth. We would all be dead. So we can assume that if the user puts in something that far out of the expected range, then it is very likely a typo and it should not be processed. Because then they may get back the answer and be confused about, why this temperature is considered hot, moderate, or cold, when really it's just crazy outside of the range. So if they put in, if they were trying to put in 15 degrees, and let's say they accidentally type a second 5 and they put in 155, then they would be confused as to why it says the current temperature is hot when they were trying to put in 15 degrees and it should say the current temperature is cold. So you can see how that could lead to problems. We want to help the users out as much as possible so that even if they make a typo, it will let them know that there is an issue that they need to correct. So we can compare the two flow charts here. Added to the original is a while loop. So while current temperature is greater than 150 or current temp is less than negative 130, which, by the way, I googled these temperatures, and these are like the most extreme temperatures that have been recorded on Earth. So pretty much if anything is above or below these temperatures, then it's invalid. So remember our or keyword as well indicates that if either one of those conditions are true, then the entire condition is considered true and it will take that loop path. So if it's outside this range, then it will output a message that says invalid input. Please enter a temperature between negative 130 and 150 degrees. Okay, so this lets them know that what they put in was invalid, and it tells them the range that they can put in temperatures between. Then it gives them an opportunity to input the current temp again. So it gives them a chance to try again. Whatever they put in here will replace the value that was assigned up here. And then it will check again to see if they have corrected the problem. As long as it's still outside of that range, it will continue to give them that error and let them retry it. But if not, if they correct it, then it will proceed to the if statements that we used before. So that just filters out a lot of invalid input and lets the user know what they can and cannot put in.